Hello students, it's Mr. Wilsey, and in this video we're going to be looking at the Algebra 1 objective on substitution. Now remember, the goal of solving a system of equations by substitution is to find the value of x and y that will make both equations true at the same time. Now, in order to solve a system of equations by substitution, so using this particular method, we need to show our work each step of the way. Because in this objective, I'm not so much concerned that you can solve a system of equations, because you can do that in a calculator easily. What I'm more concerned about is that you can substitute. Okay? So let's see what exactly that means, substituting. So in the first problem here, we have two equations. We have a system, y equals 3x minus 11, and 2x plus 3y equals 0. Now, in order to find the value of x and y that makes both equations true at the same time, what we're going to do is we're going to recognize that in the first equation here, this says that y can be replaced by 3x minus 11 in the second equation. So 3x minus 11 is going to go into the second equation. We are substituting 3x minus 11 for y. So let's write out what that's going to look like. 2x plus 3 times, in parentheses, 3x minus 11. There we go. We have substituted. Now, we have one equation with one variable, x, so we can solve it for that variable. So what we're going to do is, first of all, distribute the 3 into the parentheses. So 2x plus 9x minus 33 equals 0. Combine like terms. 2x plus 9x is 11x minus 33 equals 0. Then we're going to add 33 to both sides. 11x equals 33. And then finally we're going to divide both sides by 11. So this means that the value of x is 3. Now, we are not quite done yet. We found the value of x that will make both equations true at the same time. Now we need to find the value of y. So what we're going to do is we're going to take this value for x and we're going to stick it into the first equation. Now we can plug it into either equation that we want, but the first equation is already solved for y. So this will make our lives a lot easier if we just stick in 3 for x. So y equals 3 times 3 minus 11. All I did was substitute 3 for x. 3 times 3 is 9. So y equals 9 minus 11 is negative 2. Okay? So now we have a value for x and we have a value for y. Now, the way to write this solution up here is as an ordered pair. Parentheses, the x comes first, 3, and then the y, negative 2. That is the solution. So that wasn't too bad. Now let's look at the next problem. We're going to be doing the same exact method, substitution, in order to solve this one. X minus 4y equals 11, and 5x minus 7y equals 16. Now the first thing that I notice is that neither of these equations start solved for y, like we had up here. So that means that we need to solve at least one of the equations for y, or we can solve one of the equations for x. It doesn't matter, whichever is easiest. Now as I look here, it looks like the easiest variable to solve for is x in the first equation, because there's only one step I need to take in order to solve that equation for x. X minus 4y equals 11 is the first equation. Now if I add 4y to both sides of the equation, look at what we get. X equals 11 plus 4y. Okay? So I've got an equation that's solved for x now. Now, just like what I did up in the first problem, where I had an equation solved for y, I can take this expression, 11 plus 4y, and I can stick it into the second equation wherever I see an x. So let's write what that would be. 5 times, in parentheses, 11 plus 4y minus 7y equals 16. So now I have one equation with one variable, y. Let's solve it for y. First thing we're going to do is distribute the 5 into the parentheses. So 55 plus 20y minus 7y equals 16. Then we're going to combine like terms. 20y minus 7y is 13y. I'm going to keep the 16 and the 55 the same. Next step, we're going to subtract 55 from both sides. So 13y equals 16 minus 55. Let's see here. (16 minus 55 is negative 39. And then the last step is to divide both sides by 13. Kind of running out of room here. So this is y equals negative 39 divided by 13. That is negative 3. Okay? So we found a value for y. Fantastic. We're not done yet. We need to find the value for x. So what we're going to do is we're going to take this number for y and let's plug it in to this equation, which is already solved for x. So that'll make our lives a little bit easier. Well, it's getting messy here, but you get the idea. X equals 11 plus 4 times y, which we just discovered is negative 3. So x equals 11 minus 12. So x equals negative 1. Okay? So now we are done. We found an x, we found a y. The way that we're going to write our solution is as an ordered pair. Negative 1, comma, negative 3. All right, cruising along. Now, let's take a look at the last problem here. Solve this system of equations by substitution again, and then keep all numbers as fractions. Uh-oh. So, Mr. Wilson is telling you that there's going to be fractions involved in this one. I hate fractions. Now, just like in the first problem, let's try to identify which variable and which equation is the easiest to solve. So let's see. I could solve the top equation for x, or I could solve it for y. I could solve the bottom equation for x, or I could solve it for y. Hey, look at that. The second equation here, it would only take me one step to solve that equation for y. Look at what I'd do. I would add 4x to both sides, and in one step, we have y equals 4x minus 1. That's a piece of cake, right? So now I have an equation to solve for y. So I'm going to take this expression, 4x minus 1, and I'm going to stick it into the first equation, wherever I see y. So 2x minus 8 times, in parentheses, 4x minus 1 equals 3. Okay, just like over here and up here, we have an equation in one variable. We can solve it. So, first step, distribute. Starting to get the hang of this by now? I hope. 2x minus 8 times 4 is 32. Sorry. 2x minus 32x plus 8 equals 3. Combine like terms. 2x minus 32x is negative 30x. Then we're going to subtract 8 from both sides. Negative 30x equals negative 5. So finally, the last step is to divide both sides by negative 30. So x equals positive 5 over 30. And if you want, we can simplify that fraction. 5 divided by, well, just to show you, negative 5 divided by negative 30 is the same thing as 1 over 6. So x equals 1/6. Okay? So we found a value for x. We're not quite done yet. Let's now take this number and plug it in to that equation wherever we see an x. Okay? Because this one is solved for y. So it'll be really easy to see that y equals 4 times 1 over 6 minus 1. Now let's solve this equation, or let's simplify it. Y equals, what's 4 times 1 over 6? Actually, let's just plug this whole thing into a calculator. 4 times, in parentheses, 1 over 6 minus 1, negative 1 over 3. Negative 1 over 3. Okay, so that is it. We are done with that problem and with its objective. Ordered pair is x comes first, 1 over 6, comma, negative 1 over 3. Okay, that is it. We are done with substitution.